Every day we see the sun as a calm, yellow ball in the sky. It gives us light, warmth, and makes life on Earth possible. But inside, the sun is not calm at all. Sometimes our star has crazy days and throws huge storms of energy into space. These are called solar storms. Today we'll learn what a solar storm is, how it starts, what it can do to Earth, and why it can also make beautiful lights in the sky called auroras. The sun isn't a solid ball, it's a huge sphere of very hot gas and plasma, mostly hydrogen and helium. In the very center, called the core, it is extremely hot and dense. There, tiny atoms of hydrogen are pushed together and turn into helium. And this is called fusion, and it releases a massive amount of energy. That energy slowly travels out through different layers inside the sun. When it reaches the outside, it escapes as light, heat, and other kinds of radiation. The surface we see, called the photosphere, is like boiling water, full of bubbles of hot gas going up and down. Above that is a thin, very hot layer called the corona, which stretches far out into space. All of this hot gas is moving and makes a strong magnetic field, like a giant, twisted magnet. The sun's magnetic field isn't smooth. It gets twisted, crossed, and tangled in many places. In those spots, dark patches appear on the sun. These are called sunspots. Sunspots are a bit cooler than the area around them, so they look darker. But many are bigger than the entire Earth. Sunspots are like stress spots, where the magnetic field is very strong. The number of sunspots goes up and down in a pattern that takes about 11 years. This is called the solar cycle. When there are lots of sunspots, the sun is very active, and solar storms are much more likely. In areas around sunspots, the sun's magnetic field lines twist and bend like rubber bands. Sometimes they get so tangled that they snap and reconnect in a new way. When this happens, a huge burst of energy is released. This is called a solar flare. It looks like a very bright flash on the sun's surface. One big flare can release as much energy as hundreds of millions of powerful bombs exploding at the same time. Solar flares send out radiation in many forms, from radio waves to X-rays and gamma rays, much of which we can't see with our eyes. The light from a flare takes about 8 minutes to reach Earth, because that's how long light needs to travel from the sun to us. Scientists group flares into classes like C, M, and X, with X-class flares being the most powerful. Solar storms aren't just flashes of light. The sun can also throw giant clouds of hot gas and magnetic fields into space. These are called coronal mass ejections, or CMEs for short. Imagine a huge bubble of plasma blasting away from the sun's outer atmosphere, the corona. These bubbles can travel at millions of kilometers per hour. A fast CME can reach Earth in less than a day, while slower ones might take a few days. But don't worry, not every CME hits us. They shoot out in all different directions, and only the ones aimed right at Earth can cause any big effects here. Luckily, our planet isn't just a sitting duck. Earth has a giant invisible shield called the magnetosphere. It's a magnetic field that surrounds our planet and pushes away most of the charged particles from the sun. We also have a thick atmosphere, like a cozy blanket of air that protects us from a lot of harmful radiation. Thanks to this amazing two-part defense system, solar storms don't directly hurt people on the ground. But when a really big CME slams into our magnetosphere, it can shake it and stretch it, kind of like a drum. This cosmic shaking is what we call a geomagnetic storm. So what happens when a solar storm does hit Earth's magnetic field? Well, some of those solar particles can sneak in near the north and south poles. As these speedy particles crash into gases high up in our atmosphere, like oxygen and nitrogen, they make the gases light up. This creates those beautiful, glowing patterns in the sky we call auroras, or the northern and southern lights. Green light often comes from oxygen at lower altitudes, red from oxygen higher up, and blue and purple light usually come from nitrogen. During strong solar storms, the auroras can get much brighter, and can even be seen much farther from the poles than usual. So when we talk about a solar storm, it can mean a few different things. There are solar flares, which are those big flashes of radiation. There are CMEs, the giant plasma bubbles we talked about. And there are geomagnetic storms, which happen when a CME hits Earth and shakes our magnetic field. These storms can mess with our technology. Satellites can be damaged, and radio signals can get all staticky, making it hard for planes and ships to communicate. Strong storms can even create extra electrical currents in power lines on the ground, potentially causing blackouts. GPS signals can also get less accurate. That's why sometimes during big solar storms, airplanes change their routes to fly away from the poles, just to be safe. It's a fascinating dance between the Sun and Earth. History has seen some truly massive solar storms. The most famous is probably the Carrington event back in 1859. This storm was so intense that auroras, the northern and southern lights, were seen as far south as the tropics. Back then, messages were sent through telegraph wires. During the storm, these wires sparked, and some even caught fire from all the extra electrical current. Even in more recent times, solar storms have caused big problems for satellites and knocked out power grids in several countries. These huge events are a powerful reminder of just how much energy our sun can blast our way. But today, we're not just waiting for the next big one to hit. We have a whole fleet of space missions and solar observatories watching the sun around the clock. Some satellites stare directly at the sun, using different kinds of light to spot solar flares and coronal mass ejections as they happen. Other spacecraft are positioned between the sun and Earth, acting like space weather buoys, measuring the solar wind and particles flying towards us. Using all this data, scientists can create a space weather forecast, much like the weather report you see on the news. This lets them warn power companies, satellite operators, and even airlines if a strong solar storm is on its way, giving them time to protect their systems. So with all this talk of powerful storms, should we be scared? Well, while solar storms are incredibly powerful, they're a normal part of how our sun works. Here on the ground, Earth's atmosphere and magnetic field act as a giant shield, protecting us from the most dangerous radiation. The main risks are to our technology, things like satellites in orbit and long power lines on the ground, not to people walking around outside. This is exactly why studying space weather is so important. It helps us prepare and avoid major disruptions. So instead of being afraid, we can appreciate the sun's immense power and be curious to learn more about our amazing star. The sun is much more than just a simple light in the sky. It's a dynamic, ever-changing star, with its own seasons of calm and storm. Solar storms teach us that space isn't empty. It has weather, just like Earth. Thanks to modern science and our network of satellites, we can now watch the sun, predict many of these storms, and safely enjoy the spectacular light shows they create, like the auroras. So the next time you see a picture of the northern lights or hear about a solar flare on the news, you'll know you're witnessing the incredible power of our star in action. Thanks for watching, and don't forget to subscribe for more space adventures.